Fueled by the convergence of smart technologies, today's changing state of warfare is rapidly accelerating, bringing with it an increasing reliance on one of the most essential aspects of combat, ISR, of which the unmanned aerial system is becoming an ever more critical component. Yet before insertion, this level of complex technology must be designed, tested, and validated in the virtual world of engineering simulation. There is simply no other way to maintain the technological edge for the warfighter. The commercial and industrial world has already demonstrated the power of advanced simulation. The same benefits can apply to the development of advanced military technology. One study clearly demonstrates the power of simulation-driven engineering, helping to accelerate time to insertion, greatly supporting affordability. These remarkable reductions are accomplished at the same time product performance and reliability are greatly enhanced. There is simply no other company that offers a proven, systems-level simulation platform that can engineer the unmanned systems of the future. The performance imperatives for tomorrow's fleet of unmanned aerial systems requires improvements in multiple areas related to endurance, delivering a persistent presence. To do so, engineers must balance several design considerations, such as highly efficient aerodynamics and flight controls, size, weight, power efficiency and cooling, integration, capability, and modularity. The trade-offs and engineering options are infinite, but they are solvable only with a systems-level simulation platform like Ansys. Still, the challenges don't stop there. The UAS of the future will be required to fly in hostile airspace and counter anti-access aerial denial threats. Smart, robust, and resilient solutions will support survivability. Stealthy designs will be an absolute necessity. Simultaneous communications across numerous connected assets will add layers of complexity and detectability. Robust designs will have to withstand the intense stresses of battle. The engineering complexities are immense, but they are magnified even further by the unpredictably harsh and hostile environments of war. And the future brings even more complexity. Pilots will control not just a single fighter, but a fleet of teeming drones, all in perfect sync with each other. The engineering challenges posed by unmanned aerial systems are not only numerous, they are interdependent, multidisciplinary, and can mean the difference between mission success or mission failure. To conquer these challenges, Ansys offers several advanced and interconnected applications to help engineers rapidly and affordably create the unmanned systems of tomorrow, so you can realize a clear technological advantage.